Welcome back to 3 Inquisitive Kids. In this video, we will be talking about basic translations. This is part 1 to lesson 2 of this chapter, chapter 10. Here's our course outline for this chapter. In our last lesson, we were introduced to what translations were. So how can we perform some basic translations, and how can we put those translations together? We will be learning that in these 2 videos. Our learning goals for today is to understand and master the change of coordinates during translation, and understand how the coordinate plane actually connects algebra and geometry together. It's like a bridge. Do you still remember what is translation? Well, we know that it's a geometric transformation that moves every point of a figure or shape by the same distance in a given direction on a plane. What are the properties of translation? Well, after you translate something, the size and shape remains the same, but the shape's position changes. And the lines created by connecting corresponding points are parallel and equal to each other. That's the main points we learned in our last lesson. Answer the following questions according to the figure to the left. Move point A to the right by 5 units to get A1. What are the coordinates? Well, we're going to move it to the right by 5 units. So we're left with A1. As you can see, the answer would be 3, -3. Now we're going to move point A to the left by 2 units to get A2. And now its coordinates are -4 and -3. Now I want you to move A upwards by 4 units to get point A3, and then move it downwards by 2 units to get point A4. Its coordinates would be -2, 1, and -2, -5. What did you find after translating? So when you translate a point to the left by a certain amount of units, it would be expressed as x, the x coordinate changes, minus b, y. When you translate it to the right, you are still changing the x coordinate, x plus b. When you move it upwards, you are changing the y coordinate, which becomes x, y plus b. And when you translate the point downwards, it's the exact opposite, x, y minus b. So that's a pattern we can find after what we just did. On the Cartesian coordinate plane, point A, -3, -5, is translated upward by 4 units and then to the left by 3 units to point B. The coordinates of point B is blank. So we have -3 and -5. It's translated upwards by 4 and then to the left by 3, which means we have to subtract 3 from the x coordinate and add 4 to the y coordinate. The y coordinate was originally -5 and the x coordinate was originally -3. So -3 minus 3 equals -6, and -5 plus 4 equals -1. Therefore, its coordinates are -6, -1. I want you to translate point A to the left by 5 units to get coordinates blank, and then translate point B upwards by 3 units to get coordinates blank. If you already master the pattern of moving points and translating points, you don't have to draw out a graph anymore. All you have to do is use numbers. The answer to the first problem is -8, 3, and the answer to the second problem is 4, -2. The coordinates of the 2 endpoints of line segment AB are A and B. Translate AB up by 2 units to get line segment A prime B prime. Find the coordinates of the endpoints of A prime B prime. How are you going to approach this problem? Well, all you have to do is translate each point separately and then connect the dots to result in your translated line segment. A prime is 1, 3 and B prime is 4, 6. Line segment CD is obtained by translating line segment AB. The point A, -1, 4, corresponds to point C, 4, 4. Point B, -4 and -1, corresponds to point D. What are its coordinates? A is on AB and C is on CD, and they correspond to each other. When you look at its coordinates, you can see that the y coordinate did not change, which means that AB was moving horizontally to get CD. How does -1 get to 4? well, it has to add 5. So we can see that line segment AB was translated to the right by 5 units. And point D's x-coordinate would be -4 plus 5, which is 1. And since we are only moving horizontally, the y-coordinate does not change. It's -1. Label the following points on this graph and then connect the dots to see what figure you get. First is 0, 0. I have no idea why the points are shaped like this, but just go with it for now. 5, 4, 3, 0, 5, 1, 5, -1, 3, 0, 4, -2, and 0, 0. Then we're going to connect the dots to get this figure. Number 1. What happens if 2 is added to the x-coordinate of each ordered pair? Well, when you add 2 to each of the x-coordinates to each of the points, we're going to be actually moving this entire figure to the right by 2 units. So this figure is ended up translated to the right. When you subtract 2 from the x-coordinate of each ordered pair, you're moving it to the left to get this figure. When you add 2 to the y-coordinate of each ordered pair, you are moving this entire figure upwards by 2 units. And when you subtract 1 from each y-coordinate of each ordered pair, you're technically moving this entire figure down by 1 unit. How will the figure move when its coordinates change as follows? Number 1, x, y plus 4. This means that we are moving vertically and y is increasing by 4 units, which means that we are translating this point 4 units up. X minus 4 means that we are moving this point 4 units to the left. Y minus 2 means that we are translating this point 2 units downwards. And x plus 2 means we are moving this point 2 units to the right. Here's a problem to expand your thinking. Point A minus 2, 3, in the Cartesian coordinate plane is translated to the left by 1 unit to result in a point located in the second quadrant. What is the range of the value of A? Because A minus 2 minus 1 has to be less than 0, therefore A is less than 3. So we can first view A minus 2 as a whole because that is what we are given in our ordered pair. And we have to subtract 1 from it because we are moving this point to the left by 1 unit. And in order for it to be located in the second quadrant, its x-coordinate has to be less than 0. So A minus 2 minus 1 is less than 0. When you simplify, you get A is less than 3, which means our answer is B. We are given point m minus 1, 2m minus 1, and point Q, m squared plus m, m plus 1. If point Q is the result when translating point Q horizontally, find the value of m and determine the direction and distance of the translation. I'll give you a hint. You might need to use some algebra in this problem. Well, if we know that this point is being translated horizontally, then it means that their y-coordinates remain the same. So 2m minus 1 equals m plus 1. Therefore, when we simplify, m would equal 2. So then the coordinates of point P is 1, 3, and the coordinates of point Q is 6, 3. When you observe the coordinates, you can see that this point was translated to the right by 5 units. Can point Q be obtained by moving point P up and down? Explain your reasoning. Well, we have to prove that point Q can only be the result of point P translating horizontally, not vertically. So how can you prove that? Well, we can first assume that it can be obtained by moving point P up and down. If that's true, then their x-coordinates, m minus 1 and m squared plus m, must be equal. When you simplify, you get m squared equals -1. But no number squared can equal a negative number, which means that this does not make sense. This is not equal. So if this does not make sense, then our original assumption that point Q was obtained by point B moving up and down is wrong. The coordinates of vertices A and B of triangle OAB are A, 1, 3, and B, 4, 0. Translate triangle OAB to the right along the x-axis to get triangle CDE. If CB equals 1, the coordinates of point D are blank, because you don't have any tick marks on the x and y axes. So how can you solve this problem using what we already know? So A is 1, 3, 1, 3, and B is 4, 0. Triangle OAB was translated to the right along the x-axis to get triangle CDE. CB equals 1, so that's 1 unit. Coordinates of point D is blank. In order to know the coordinates of point D, we have to know how much this entire triangle was translated. What was the distance? CB is 1, and B is 4, 0, which means that C is 3, 0. That's 1 unit less than B. And we know that O is the origin. And we know that O and C correspond to each other. If we have 0, 0, and 3, 0, we can see that this entire triangle was translated to the right by 3 units. And now, in order to find the coordinates of point D, we have to do 1 plus 3. 1 is the coordinate of point A plus how much it was translated, which is 3 unit, comma 3. We get 4, 3. Calculate the area created when dragging line segment OA during translation. So now it's talking about how much this yellow part is. We can see that this yellow shaded area is a parallelogram, which means we can use area equals base times height. So what is the base? What is OC? And what is the height? In other words, what is the y-coordinate of A and D? Well, we know that its length would be 3 units because this entire figure was translated 3 units. And when we go back, the y-coordinate of A and D is both 3. So the height is 3, and the length is also 3. 3 times 3 equals 9. That's our answer. Class summary. Today we'll learn about some basic translations on the Cartesian coordinate plane. When we move a point along the x-axis and along the y-axis, they each have some patterns. The y-coordinate remains the same when we move a point along the x-axis, and we can increase the x-coordinate in order to translate right, and decrease the x-coordinate if we want to go the opposite direction. It's the same with the y-axis. The x-coordinate remains the same. When we want to move something up, we increase the y-coordinate. When we want to move something down, we decrease the y-coordinate. And that's the main points we needed to summarize in this lesson. I hope you enjoyed this video, and be sure to come back for our next lesson.